This is a presentation on limiting reactants, also called limiting reagents, section 12.3 of the books. Let's take a look at the definition for a limiting reactant. A limiting reactant will produce the least amount of product during a chemical reaction. So limit, it's going to limit the amount that is made. The other type of reactant in there, let's say for example if you have two reactants, is called the excess reactant. That is the reactant that will be left over at the end. So our limiting reactant will tell us how much product will be formed. That's going to be our final answer. We need to utilize that limiting reactant to determine how much product is formed at the end. First thing we need is a balanced equation. Let's say, for example, we'll do an analogy with bicycles. You're building a bicycle that involves one frame and two wheels. So you know that you need one frame and two wheels to make one bicycle. So you can also talk about moles. 1 mole of frames and 2 moles of wheels gives you 1 mole of bicycle. So you need twice as many wheels as bicycles you will make in the end. So let's say, for example, you had 10 moles of frames and 16 wheels. How many bicycles can you make? This is a limiting reactant product. You're going to have to figure out how many bicycles you can make from each of your reactants. So let's start with frames. If you started with 10 moles of frames, do your dimensional analysis. Parentheses, line, moles of frames in the denominator. You want to figure out how many moles of bicycles you can make, so you put that in the numerator. You know that for every 1 frame, you make 1 bicycle, and that's where these numbers come in, 1 and 1. So we can make 10 bicycles with those 10 frames. If you take a look at the wheels, if you have 16 moles of wheels, parentheses line, moles of wheels in the denominator, moles of bicycles in the numerator again, you know that for every 1 bicycle, you need 2 wheels. So when you do this calculation, you will end up with 8 bicycles. So that's our answer there. 8 bicycles is the limiting reactant. That will limit us on how many we can make. We're going to run out of wheels before we run out of frames. So the excess reactant will be the frames. Let's do a sample problem here with some actual chemicals. A mixture of 1.5 moles of aluminum and 2 moles of chlorine react. What is the limiting reactant and how many moles of aluminum chloride are formed? So here we have our balanced chemical equation. Remember, it needs to be balanced. That's key to do this. And again, this will tell us that 2 moles of aluminum react with 3 moles of chlorine to produce 2 moles of aluminum chloride. So it's just going to be our mole conversion problems that we did before in the earlier sections. So we're going to want to start off with each of our raw materials. Our 1.5 moles of aluminum is what we'll start with here. Parentheses line, moles of aluminum in the denominator. Moles of aluminum chloride, since that's what we're trying to figure out, in the numerator. And then we look at the coefficients. This is our mole ratio, just like we did last section. We have 2 moles of aluminum, and we have 2 moles of aluminum chloride. That's where those 2 numbers come in. Moles of aluminum will cancel. We take our 1.5, multiply it by 2, divide it by 2, and we will again get our answer of 1.5 moles of aluminum chloride. We do the exact same thing with the chlorine, but now we're starting with 2 moles of chlorine. Do the same conversion factors, except we have moles of chlorine in the denominator here. We still have that moles of aluminum chloride in the numerator. From the balanced chemical equation, you can see we have 3 moles of chlorine, so our 3 moles go down on the bottom there. And we will end up with 1.3 moles of aluminum chloride. So again, our 1.3 moles of aluminum chloride is going to be our limiting reactant. Actually, that's the amount of product that's going to be made. The limiting reactant will be the chlorine because it produces the least amount. The least amount we're going to run out of the chlorine before we run out of the aluminum, just like we ran out of the bicycle tires before we ran out of the frames. So that's going to be our limiting reactant, and so we produce the least amount. So 1.3 moles is how many moles we will produce. Let's take a look at your limiting reactant worksheet. Let's work out problem 1A. Make sure everybody's on the right page, going at this the correct way. Here we have our chemical reaction. It's already balanced for us. That's the first thing you're going to want to check to see if it's balanced. We have 1 mole of hydrogen and 2 moles of chlorine. Question is, which is our limiting reactant? Start out with what we're given. 1 mole of H2. We're also given, in our second setup here, 2 moles of Cl2. So we're going to have 2 separate problems that we're going to work out. We'll do this first one on top here with hydrogen. Deal with your units first. Moles of H2 goes in the denominator. We're trying to figure out moles of HCl. Is it what we're trying to produce? So now we look at our coefficients from the balanced chemical equation. For H2, it is 1. For HCl, it is 2. So that's what we'll use. Our moles of H2 will cancel, and we will end up with 2 moles of HCl. Do the exact same thing for our next problem here. Moles of Cl2 in the denominator. We're trying to find moles of HCl, so that goes in the numerator. Get your units down, and then you can look at the numbers. Moles of Cl2 is 1. Moles of HCl, again, will be 2. Now we'll have our 2 times 2 divided by 1, which will give us 4 moles of HCl. So we know at this point our limiting reactant is our H2. Limiting reactant is the H2, and we will produce 2 moles of HCl. We're going to run out of H2 before we run out of chlorine. This concludes our presentation on section 13, or excuse me, 12.3. Hope you enjoyed it.